Practice Set 7, page 26, problem number 1. $5,000 is invested at 7.25% interest compounded quarterly. Find how much money is accumulated in 1 year and 5 years. This problem involves using the compound interest formula, where T is the total amount, is found by taking P, the principal, the initial investment, times the quantity 1 plus R, the interest rate, divided by N, the number of compounding periods per year, raised to the N, same value, times T, the time in years that the account has been compounding. So for this problem, we have $5,000 being invested. That's our principal. The 7.25% is our interest rate. It tells us that this account is compounding quarterly. The number associated with quarterly, since there are 4 quarters in a year, means we're going to use N is equal to 4. And part A says, what is that total balance after 1 year? That will be our T for this first part of the problem. So to find the total amount, we're going to take the principal, $5,000, times 1 plus the interest rate, expressed as a decimal, 0.0725, divided by N, the number of compounding periods, and this is quarterly, so we're going to put a 4 in there, raised to the 4, which is our N value, times T, which is 1. Simplifying this, following the order of operations, we'll simplify inside the parentheses first, and the division is our first priority. Since there's 2 operations, division is stronger or has a higher priority than the addition. So doing that division, 0.0725 divided by 4, results in a value of 0.018125 raised to the, and since I'm having to rewrite this, I'll do the multiplication. 4 times 1 is 4. Next, we'll add the quantities together that are in the parenthesis. So we have 5,000 times 1.01825 raised to the 4th power. Next, we have multiplication and an exponent. The exponent has the highest priority following the order of operations. So that will give us 5,000 times, here's where you would use your exponent key on your calculator. And I would leave this number in my calculator. I'm not going to round it, so I'm going to indicate here the value that I had when I took this value, 1.01825, to the 4th power. If you leave that in your calculator, the last operation then is to multiply it by 5,000. If you round this, our result isn't going to quite agree with the exact value, and the final step with that multiplication leaves us with a total in the account of $5,372, and when we round it to the nearest cent, we end up with 48 cents. The second half of this problem, the values will all stay the same with the exception of this time we will deal with 5 years calculating this problem. So setting up the formula again, our principal amount is 5,000. 1 plus R, that's our interest rate, which is still the 0.0725. N is the number of compounding periods. Quarterly means 4 times a year, raised to the N, which is 4, times T, which for B is 5 years. That time needs to be in years. Following the order of operations again, I'm going to simplify inside the parenthesis, do the division, and add 1. Will leave us with a result of 1.0125. And while we're at it, instead of writing 4 times 5, substitute in an equivalent value of 20. Next, same thing as with the last. Our priority is exponents before the implied multiplication. So using your power key on your calculator, we're going to take this quantity raised to the 20th power, which results in 1.43226056. I would leave that in my calculator, the entire value, timesing it by 5,000, the last operation, and rounding that to the nearest cent leaves us with $7,161.30. That would be the balance after 5 years, given these terms.